Hello everyone, this is another video from Easy Electric series, and today we want to interface the temperature sensor with microcontroller. So first let's see which actually component we need for this project. So as usual, the first thing is microcontroller. We use TIVA C-Series Launchpad from Texas Instrument, which is a Cortex M32-bit microcontroller. So we actually use the temperature sensor. This is LM35, so you could actually buy this for $1. So from the eBay or Amazon or any other website. So we also use the LCD to indicate the temperature. So the LCD that we use is a Nokia 5110. Again, you could buy that for $10 from eBay. So as you could see, we actually interface our sensor with our microcontroller, and then we indicate the temperature on our LCD. So you could actually do this with the two different ways. So the first one is whatever you got as a data from your sensor, immediately represent that on your LCD. So the second way is because that number actually changed a lot. So what we did here, we actually take the info from the sensor for almost 30 seconds and take the average of the whole data in 30 seconds that we got from our sensor and print or indicate that average on your LCD. So let's see how it works. So let's actually reset our microcontroller. So if you reset that, so as I mentioned, we need actually 30 seconds. So the microcontroller actually read the data from sensor for 30 seconds. And after 30 seconds, it will be indicate the average of the whole data that it collected in 30 seconds and indicate that on our LCD. So as I mentioned, this actually is more accurate temperature. So you could do immediately just send whatever you got, but usually it's actually changed a lot. So as you could see here, so the temperature in average of the actually temperature or data that we got in the last 30 seconds is 24 Celsius, which is the almost temperature, the room temperature. So let's see how we actually code this and how we could interface this sensor with actually our microcontroller. So I'm just show the important part. Definitely you know the all other simple parts. So I just want to more focus on how you could take a 30-second average of your info. So if you actually check your loop here, so inside the loop, the first actually we use the Energia for actually the coding. So as you could see here, we inside the loop, you actually use one while one, which is repeat this while one. Whatever you have inside your while one, it's actually repeat to implement that code. So you start with the milliseconds function. So whenever you use this function actually somehow shows the current time. So you actually know what time is it right now. The unit is millisecond. You actually save that inside this starts, and then you use a do while loop. So as you already know, the do while is implement first time whatever you have inside the do, then check the condition that you have here. So in this condition is true, so it's actually start to repeat whatever you have inside the do. So this is what we have in condition. We say now, that means you know what time is it right now, and save that inside this start, and then you have the now, which is the inside this do loop. So that means you record the time, so then you read whatever you have from your IO, which is the information of your sensor. So that's a digital number. So you actually multiply that digital number to your resolution. So in TIVA C series, the resolution actually is 3.3 divided by 2 power 12, which is this number that you see. If you actually say the whatever you read times the resolution, definitely it give you a voltage that you have on your sensor. So this is actually the voltage that I get from the sensor. So then I actually times that with 1000. So that means the unit of this voltage that you see is millivolt. So if you check the data sheet of the LM35, so the LM35 usually for one degree of the Celsius, it's actually changed 10 millivolt. So that means whatever you have here as a millivolt, if you divide it by 10, so whatever you get is the degree or is the Celsius. So that's what's happened. We actually have this, which is the millivolt. We divided by 10. Whatever you get is the temperature in the Celsius. So this is actually the first data. You start here, you got actually one temperature, but I don't want to immediately print this on my LCD. I want to take average of at least 30 seconds and print that average. I'm do this because whenever you take average in 30 seconds, you actually get more accurate temperature, more accurate data. So that's what you have, these new variable temp average. So it is plus equal temp. So that means you got this temp, you actually save that inside the temp average. So then you already initialized n is 0, then you actually count how many actually times you actually get the data. You need these n because you want to take the average, right? So you need to n, if you divide this temp average by n, it gives you actually the average of that. Then you actually say now equal the again milliseconds. So that means here you record when you start. So here you know right now what time is. That means how long it takes you move from here to here. So you want to actually that for 30 seconds. So that means this condition is if now is smaller than start from 30,000. This unit is millisecond. So 30,000 actually is a 30. This is 30,000 milliseconds. So or 30 seconds. So that means I know what time is it right now. Here I record that. Then I actually, whenever I got one data, I actually again save record the time. So then I check my current time, which is now. It should be there whenever I start plus 30 seconds. If it is actually is smaller than, that means it's still I'm not actually past the 30 seconds. So that means you actually repeat this loop. So that means I repeat this loop for how long? For 30 seconds. So that means I read the data from the sensors in 30 minutes and save all of them inside this temp average. Then here, whenever I'm done, that means if I'm over the 30 seconds, so I already record the n. I just have the whole total of that data, then divided by n. So that means you actually get the average and save that inside the temp average. So then you have that average actually data. Then you just need to print these average that you have here, which definitely you could do that. So that means you actually, if you want to print that on the LCD, so definitely you could do that. You just need to print this on the print this temp average on your LCD, and then you're actually able to see what you have. So again, the advantages of this is you actually indicate the average of the whole data that you got in 30 seconds, which is give you a more accurate info. So I hope you like these videos.